two projects. In this video, we are going to explain about the project that is a survey on spatio-temporal big data analytics ecosystem, resource management, processing platform, and applications. So, before getting into the execution, first let us understand what is the project about. So think about how traffic works in a city. It is never the same all time, right? Some roads are packed during rush hours, some areas get jammed because of sudden roadblocks. And sometimes traffic just builds up unpredictably. Now with the rise of the internet, that is internet of things like smart sensors, GPS and cameras and better data collection methods, we have access to huge amount of traffic related data. But just having data isn't enough. The real challenge is making sense of it and using it to predict congestion before it happens. So that's where spatial temporal big data comes in. This type of data isn't just about where the traffic is, that is spatial, but also when it happens, that is temporal. So by combining both, that is spatial and temporal information, by combining this both spatial and temporal information, we can analyze the past traffic patterns, understanding how congestion builds up, and make better decisions, that is predictions for the future. For example, if a certain road gets crowded every Monday at 8 a.m. and this SCBT based system can recognize this pattern and alert drivers in advance. So, why is this important? Because real time congestion prediction helps in so many ways: shorter travel times, better traffic flow, less fuel wastage, and even reduce pollution. Plus, it helps city planners and transport authorities make smarter decisions like adjusting traffic signals dynamically or planning road expansions based on the real data rather than just assumptions. So, in simple terms, SDBT isn't just about collecting traffic data, it is about using that data smartly to predict congestion and improve the way we move around cities. And here, predicting traffic congestion isn't as forward as it seems. Roads are unpredictable. One day a route might be smooth and the next time it's jam packed because of an accident, bad weather or just an unusual surge in vehicles. So that's the challenge. Real world traffic is messy and dynamic and no single pattern can fully capture its randomness. One big issue is that traffic data comes from multiple sources, that is GPS, road sensors, cameras, mobile apps, and even social media updates. But all this data isn't uniform. It is heterogeneous, meaning it comes in different formats and from different systems, making it tough to process efficiently. On top of that, traffic conditions change in real time. So, any prediction model needs to work fast while still being accurate. That's where most existing systems struggle. They either take too long to analyze the data or aren't precise enough to truly useful. And then there are external factors like road repairs, bad weathers, festivals, or sudden lane closures that disrupt usual traffic pattern. A system that doesn't account for these unpredictable events won't be very reliable. So the key challenge is building a model that not only predicts congestion accurately but also adapts to unexpected changes. And why does all this matter? Because better congestion prediction means better traffic management, optimized traffic signals, smarter route planning, and fewer delays. Ultimately, solving these challenges is what will help cities move towards smoother, more efficient, and less frustrating communities for everyone. So, here the idea is to use big data and also deep learning models to predict traffic congestion more efficiently. Instead of just relying on traditional methods, which might not handle large scale data well, the system takes advantage of spatio-temporal big data, basically traffic data that changes over time and across different locations. So, here is how it works. First, we are dealing with a massive amount of traffic data, which means regular processing methods won't work with it. So that's where Hadoop and Apache Spark comes in. These tools break down the data and process it in parallel, making it faster and more efficient. They help extract useful features from the data like peak traffic hours and road conditions and congestion patterns. And then we actually predict the congestion. So the system uses CNN 2D model, that is convolutional neural network two-dimensional model. So think of it like how an image recognition model identifies objects in a picture. Except here, it recognizes traffic patterns from the historical data. Here, TensorFlow and Keras are used to build and train the model, and the hidden layers and neurons are fine-tuned to improve the accuracy. Then comes performance evaluation. So here these help, we consider R square mean R squared, that is mean squared error, and root mean squared. Once the model is trained, we need to check how well it performs. So we have used all these metrics to evaluate. So these help to measure how accurately the model predicts traffic congestion, whether it needs further tuning. And then this system scales well, meaning it can handle large data sets without slowing down, and it can give more accurate congestion prediction compared to traditional methods. In the long run, it means better traffic management, smarter route planning, and less time wastage in traffic jams. So this is the proposed system. And to further improve the performance of this project, to do the traffic congestion prediction even better and faster, here we are incorporating multiple models. That is hybrid CNN model, it is introduced. That is basically it is combined with two powerful models. So here first we have combined CNN by LSTM. CNN is convolutional neural network. It is great at recognizing spatial features, meaning it looks at how congestion changes across different locations. And we have integrated by LSTM with CNN, that is bidirectional long short-term memory. It focuses on temporal dependencies, meaning it understands how congestion evolves over time, whether it is rush hours, weekend patterns, or whether related to traffic changes. By combining them, the model learns both where the congestion happens and when it happens, making predictions much more accurate. And also, we have additionally combined CNN with GRU. So, here we have combined CNN with GRU. So, here BiGRU, that is bidirectional gated recurrent unit, is used instead of LSTM in another variation. Why? Because GRU is a lightweight version of LSTM, meaning it processes data faster while still keeping most of the prediction accuracy. This helps to reduce the execution time, making predictions quicker without sacrificing too much accuracy. Furtherly, we have developed front end. So to make whole thing user friendly, a Flash based web interface is developed. This allows users to interact with the system easily, and it includes authentication, meaning only authorized users can access it, making it secure. And users they input details and get traffic congestion predictions, making it a practical tool for traffic management or even for everyday commuters looking for better routes. And moving on to the implementation, to implement this project, we have followed the steps mentioned in the flow of work. So these are the steps followed. Let us understand them. So first, we have imported all the necessary Python libraries that are Spark, Pandas, NumPy, TensorFlow, Keras, Matplotlib for data processing, machine learning, and visualization. And then we initialize Spark session. So here we create a Spark session to enable distributed computing, and we set up Hadoop HDFS to efficiently process large scale data efficiently. And then comes loading the data set part. So here in the step, we read the traffic data using Spark and convert it into a Pandas data frame for further analysis. Then comes exploratory data analysis part. So here in this step, we display the basic statistics that are mean, min, max, etc. to understand dataset properties. And we identify and fill the missing values with zero to avoid errors in the processing. Then comes data visualization. So here we generate graphs to visualize trends in the traffic congestion. We use bar charts, line plots, and pie charts to analyze traffic direction and congestion levels. Then comes data processing. So here we convert date and time into separate numerical features like year, month, day, and hours, etc. And we apply label encoding to convert all the categorical values like weather and road direction into numbers. And we normalize data using min-max scaler to bring all feature values into a common range. Then we split the data into train and test, where training set is used to train the model and testing set is used to evaluate the model. Then comes model building. So here we construct a CNN based deep learning model for congestion prediction, and we also initiate the hybrid models that are CNN by LSTM and also CNN by GRU for improved performance. And then we train the model using historical data and optimize parameters like layers and neurons. And we evaluate all the models built using MSC, RMSC, and R score. That is R square score. And then we developed front end using Flash based framework to create a user interaction. SQLite database is used for strong user registration and login details securely. And user they can input feature values in the front end that will be pre-processed at the back end. It will be fed with the train model, and finally outcome will be displayed through the front end of the application. So this is how we have implemented the project. And moving on to algorithms used. So these are the algorithms used in this project to predict the traffic congestion. So this is the proposed model, and these are two models. These two models are the extension models, which is hybrid CNN by LSTM and CNN by GRU. And to implement this project, basically we need two types of requirements, that are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB and above. And software are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's execute. To execute, open the code folder that contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this folder, we have the dataset used in this project. Let's open it. So this is the dataset used to train the models for predicting the traffic congestion. It's being loaded. Just wait. So this is the data set that we have used in this project. So here we have temperature, rain for 1 hour, snowfall for 1 hour, cloud, weather. Here we have weather main, weather description, and here we have date and time, X value, Y value, direction, and congestion. So based on these features only, we will be predicting this target label congestion. Let's close this. And here this file we will be uploading in the front end to predict the traffic congestion. Let's open this file. So these are all the features that we will be, I mean, these are the different test cases that we will be giving as the input. For all these cases, we will be predicting the traffic congestion. So close this, get back. This is the model folder in which we have algorithm information that will be loaded into the project code during the runtime of the application. And here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the run.bat file. So instead of executing this project through command line interface, we have created this Windows batch file. So if we just double click on it, this project will be executed. So let's double click on that. Here, app.py file is compiled. Now, Flask framework will host the application locally at the default address, which is the local host, and the port unless configured differently. So here you can observe, right, Flask framework has hosted the application. This is the local host and this is the port. So now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Paste the link here. Click on enter. Before clicking on enter, at the end type index and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So here you can see an admin link, right? We need to click on that for logging in as admin. So click on that. Provide your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see predict traffic congestion link, right? So click on that. Here you can see a choose file button. We need to click on that for uploading the test data. So click on that. So open the data set, select the test data and now click on open. Here you can observe, right? Test data file is loaded. Now click on submit. So this given input, all the inputs that we have given, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us the prediction. So just wait for a while. File is being pre-processed at the backend. So here we got the prediction. So here are all the test cases that we have given. For each case, we got the prediction of traffic congestion. So for this case, so this is a case of first, this is the first test case that we have given. And here we got the traffic congestion is 60.48943. And here for the second case, here we got the traffic prediction, traffic congestion as 33.48. And for the next case, we got prediction as 42.6. Accordingly, we got 55.8, 57.17. For all the cases, we got the traffic congestion prediction by the given model. So now click on logout. In this way, just by giving the values to the application will predict the traffic congestion. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.